So I suggest we actually do that too. Okay. So a good definition of nanotechnology is atom by atom, molecule by molecule assembly of a complex or functional system. And by that definition, the best example of nanotechnology is life itself. You have been created atom by atom, molecule by molecule, on the basis of a DNA blueprint. So life and human beings are the results of nanotechnology. I'm going to show you my favorite molecule. It's not C60. It's this molecule, nitrosoethane, because it looks like that. It's my dog, all right? Made of carbon, hydrogens, okay, nitrogen head and red nose. My dog is rather clever, because if I look at the spectrum, and I used to be a spectroscopist, well, I am a spectroscopist, it's the only thing I know. I don't do that anymore. In fact, I'm doing things I don't know what I'm doing. But that's good in science. My dog is really rather clever, because what it does, it shakes its head, all right? And it shakes a hand and looks at its tail. Not only that, I thought I'd show you my dog's even cleverer than that, because the hydrogens undergo internal rotation, all right? It's been drinking too much sake, all right, or beer, okay? And if you've been drinking too much, you know what the problem is. You have a problem, and if you're a dog, the most important thing is a lamppost. All right, so there you go. Now the reason for showing you that, apart from the fact that little kids like it, and big kids like it, is that molecules actually are flexible. And that property of molecules has not really been used yet. I think that that property is something that is going to be very important in 21st century chemistry. And I'm going to show you why. This is hemoglobin. It's in your body now, and life has created this molecule, and it's a very sophisticated molecule. It changes its shape. It's the first molecular machine that was recognized by Max Perutz, and he got the Nobel Prize for the structure of this, and showing really that it changed its shape. And it does that because it hangs on to oxygen in your lungs where there's plenty of it, and then releases it where it's needed. It's a very sophisticated molecule. And we, so far, or certainly the drug industry, has not started to make molecules like this with this degree of sophistication. But I think you young people, in the next few decades, will do that. ATP synthase is a fascinating molecule. Here, I'll show you this molecule. It's just fantastic. Let's see it in action. What is happening here is that protons are going in here, neutralizing negative charges on this rotor. A spindle up through here is opening and shutting these cavities. ADP, adenosine diphosphate, is going into this cavity. It's putting phosphate with ADP, the adenosine diphosphate, and ATP is coming out. If I'd have seen this molecule when I was your age, I think I would be in molecular biochemistry, or molecular biology, biological chemistry, you name it. This wonderful electric motor driven by protons. The next generation of nanotechnologists will be making nanoscale motors like these, okay? And it's a very exciting possibility.